Welcome to the Week 11 spreadsheet on binomial option pricing and VBA. This workbook is comprised of two worksheets, and we're going to consider the first worksheet, eur-5. This is actually binomial option pricing without VBA, and it's similar to last week's workbook. The difference is that instead of having 3 time periods, we've now got 5 time periods going out. So let's explain. Here you have the simulation of stock prices going out 5 time periods. From the upper leaf all the way down to the lower leaf represents the stock prices at the expiry of the option. Consequently, using the traditional formula for maximum of the stock price at expiry minus the strike price here, or 0, we can calculate the value of the option at each leaf. And that's what we do here. And then, using the state price formulation that we explored last week, we can move backwards in the tree from the maturity date today and go backwards all the way back to the root of the tree, and in this way we can calculate the value of the option today. And here it's $10.43. Now problem 2 is a little bit different. Problem 2 asks you to highlight the cells in the table below based on the European pricing formula. And to explain problem 2, I'll go to the lecture. Here's the possible number of draws, outcomes after 3 draws for a binomial tree. We can have $1 and we can go up, up, and up, or we could go up, down, and up, or we could go down, up, and so on and so forth. The payoff at each leaf is u, the payoff in an up, to the power of n minus j, where j starts, it's the number of downs, d to the power of j. So that's the algebraic formulation for the binomial tree payoff at each leaf, that is the end point. Of course, there are a number of different paths to each leaf. Here you can see 3 different paths to this intermediate leaf, this middle leaf. You can go up, up, and then down. You can go up, down, and up, or you can go down, up, and up in blue. There are 3 paths to this leaf, and 1 path to this leaf, up, up, and up, and 1 path to this leaf, down, down, and down. So this information is used in this table. So, when the terminal payoff is $23.20, as you can see in this uppermost leaf here in problem 1, that corresponds to 1, 2, 3, 4 ups. So the number of up steps is 4. Consequently, the number of down steps is 0. The price, that's equal to the number of up steps to the power of 4, because there are 4 up steps, and the number of down steps, or the down steps to the power of 0, because there are 0 down steps. And then the number of paths, well, we can see that there's only 1 path to this uppermost leaf, so it's 1. And then the value. The value is equal to the terminal payoff, that is the value of the option, multiplied by the price at that leaf, multiplied by the number of paths. We do that for each and every one of these intermediate 0, and calculate the number of steps, the number of the price using the power up steps and the multiplier. If we have an up for the state prices, the number of down steps and the multiplier, the state price down multiplier, and then adding everything together to get a final option value, $10.43, which corresponds to the one we got using the binomial tree. Alright, well that's it for problem 1 and 2 in the eur 5 worksheet in the week 11 workbook.